Hello and welcome to this Electrical Science and Principles training video. Now, as you know, here at Joe Robinson Training, we're always very keen to help people out when they're struggling with their science and principles. And this week we have been literally inundated with a question. That question has come from Helio JJ on Twitter. I'm assuming that's not his birth name. And he says, at Joe R Training, currently doing level 2 electrical installation and your videos has been helping me so much. Are you able to help me with one cue that I can't really find it anywhere how to solve it? And then he goes on to give us some information. The question is, calculate a diameter of an aluminium buzz bar which is 24 meters long and whose resistance is 0.00139. I'm assuming that's ohms. And then he's put P equals 1.78 times minus 8, which again, I'm making a bit of an assumption here, but it's fairly reasonable to assume that that P is supposed to be a rho. Apparently not everybody has the Greek alphabet downloaded to their mobile device. I do. And I'm assuming that that is times 10 to the minus 8, which will be in ohm meters. So assuming my assumptions there are correct, we can probably give you a bit of a hand with this question. He then goes on in a later tweet to mention, it's very grateful for the help, which is nice, and he goes on to mention that actually the resistivity for the aluminium was 2.84 times minus 8, again times 10 to the minus 8, so which makes more sense because the previous value sounded a little bit more like the value for copper. So we've got here a resistance and resistivity question. We've got a aluminium buzz bar, we know the length of it, we know its resistance, we know its resistivity, and we want to know what its diameter is. Now this is a really interesting question. I think whoever's asked this question of Helio JJ here is a bit of a, I think it's a bit of a stretching question from a teacher to keep students busy, because it's a little bit tricky, requires a few different skills, one of which is transposition, which is always a little bit challenging. So with this kind of question, the best thing you can normally do is just start throwing the information that you know either onto your worksheet or your bit of paper, or in this case the whiteboard. So let's have a look. We've got, first of all, we know the length of the bar. Okay, so we know that it is a length of 24 meters, so that's a length of 24 meters. It's got a resistance of 0.00139. Again, I'm going to assume that that's ohms, so the resistance is 0.00139, 0.00139 ohms, and we've got a value for resistivity, or rho, of 1.7. You change that, remember? Okay, so we'll get the correct value for that because it's aluminium. We've got 2.84 times 10 to the minus 8 ohm meters. Okay, so that's what we're looking at there. And the question is asking us to find the diameter. So this is where this one gets just a little bit tricky. It's asking us to find the diameter. So we want to know what is the diameter of that buzz bar. Again, I'm going to assume that the buzz bar is circular. Otherwise you wouldn't really be asking for the diameter of it. So I'm going to assume that the buzz bar is circular in its cross section, and that's what we're interested in, that's what we're trying to find. Now, I'm sure, looking at those values, looking at those symbols that we've got on the board there, we're familiar with all of those. Hopefully we'll recognise those and we know what they are. The challenge is to find an equation that includes all of those things. So this is a resistivity question, so hopefully we're recognising what formula we're going to be using for this, and it is the formula for calculating resistance based on resistivity, cross-sectional area and length. So if you're not familiar with any of the formulas or terms or expressions that I'm using in this video, please do go back and check the videos that I've already done on resistance and resistivity, because we do that in a lot of depth and it's a really important subject for electricians to understand. So let's throw up the formula that includes these things. So we normally write it like this: R, or resistance, is equal to rho multiplied by L, the length, divided by A, the cross-sectional area. Now again, looking at that formula, you can see there's nothing here to represent D, and that doesn't include the diameter. However, hopefully we can also realise that if we can find what the area of this buzz bar is, then actually we can then use that to go and find out what the diameter will be, hopefully. So, first thing we need to do is think about transposing this formula. Now, The first thing to do on here, again, when we transpose, and I'm going to do a video on transposition, so watch out for that in the future, probably a series of videos on transposition, because it's something that learners struggle with on electrical courses. But what we're going to do is we want to get this A by itself. That's what we're trying to do. So we're trying to move this around, and the trick is to think about the order that you do things on, the order that you do things in on this side, and then you want to think about reversing that order, and that's the order that you transpose in, if that makes sense. So looking at this, we can see that we multiply these two numbers together first, and then the last thing we do is divide by the cross-sectional area. So when we transpose, the first thing will be the last thing that we do, if that makes sense. So the last thing we do is divide by A, so that becomes the first thing for transposition. And then we just do the opposite function on that symbol or number, whatever it is. So here we divide by A. So what's the opposite of divide by A? Well, it would be to multiply by A. So we multiply both sides by A. On this side, we end up with R times A is equal to, and on this side, because we've divided by A but then multiplied by A, it's disappeared, and we're left with rho times L. Been very inconsistent there. I'll put a multiply there just to keep consistency. So RA is equal to rho L. Now, what we're going to do next is we're going to try and get the A by itself. So what are we doing to the A at the moment? Well, we're timesing it by R effectively. What's the opposite of timesing by R? Of course, it's to divide by R. So we end up with A is equal to rho times L over R. And actually, just as a kind of an insider secret, that formula there is kind of your good go-to position for the resistivity formula, because from that it's very easy to figure out how to get to any one of these by itself, because you just end up, let's say you want L, you just put the rho divide by rho on that side. If you want rho by itself, you just put divide by L on that side, and it just kind of works really nicely and neatly. Okay, so the next thing that we need to do is we now need to put the numbers into our calculation. So we already know what all the values are on this side. We know what rho is. It's 2.84 times 10 to the minus 8. So we go 2.84 times 10 to the minus 8. And then we're going to times that by L, which is 24 meters. So we got all this from the question. And then we're going to divide by the value of R, which is 0.00139. Okay. What we're going to do now, to get the answer to this, we're going to head over to CalculatorCam and have a look at how to put this into the calculator. Okay, so here we are with CalculatorCam, and we'll just turn it on there for starters. Now, the way that I like to always do this kind of calculation is I always like to hit this button here. So you can put it in just exactly as we saw it on the screen a moment ago. So here we've got the fraction button. So that's that button there, which gives us a number over a number. And you can put pretty much whatever you want into those boxes. So in this case, we're going to go 2.84. Okay, so that's our value for resistivity. Not forgetting, of course, we need to put on there the times 10 to the minus 8. Okay, so just press that button for the times 10. Don't put in times 10 and then the power button. Just press that one there and it does it for you. Times 10 to the minus 8. And then we're going to multiply that whole thing by 24. So times that by 24. And then we're going to divide it by the resistance, which is 0.00139. 0.00139. And then we hit equals, and we get this for an answer. Okay, so we've got a rather ugly fraction there, so we'll change it pressing the SD button. So we'll turn that into a decimal number there. However, again, it's a slightly unpleasant number to be using, really. I don't think that means very much to many people. So if we press the Eng button here, it automatically puts it into engineering notation for us. So we've got 490.36 we'll go with. So 490.36. So we'll volley that onto the board. 490.36. And of course that is times 10 to the minus 6, as we just saw on CalculatorCam there. Now bear in mind, what we've been finding this whole time is the area. So we've got the area, the area, the area. Of course, area, the SI unit for that is meters squared. So that's meters squared. But again, looking at this, that means very little to me. I couldn't kind of visualize what that means in meters squared or how that relates to electrical installation. So because we've got this times 10 to the minus 6 here, and because we're working with area, okay, so this is a bit of an aberration in the SI system. Not an aberration, a weird logic to the SI system. This becomes 490.36. We can change that times 10 to the minus 6 in this case, just in this case because we're dealing with area, to a lowercase m for milli, and then that becomes millimeters squared. So we've just changed that bit for an m and put the meter squared on the end. So 490.36 millimeters squared, which is kind of, you can start to kind of relate that to your electrical installation work. You know that the tails for a domestic situation are normally 25 mil squared and things like that. So you can start to visualize this is a pretty chunky buzz bar that we're dealing with here. Now that's fantastic that we've got the area calculated, so that is the area, but the question isn't asking us for the area, it's asking us to find the diameter of the buzz bar, and again we're assuming it's circular and cross section. So where do we go from here? What's the next step? Well, what we need to do now is we need to figure out from our area what the diameter is going to be. Now there's a couple of different ways of doing this. I'm going to show you the simplest way first, and then we'll look at these kind of slightly more complex way, but it's the more kind of engineering way, if you like. It's the way you'd probably have to get used to if you went on to do some kind of higher learning in engineering. So let's have a look at this. Let's go for green now. So we're trying to find the diameter. That is the key point here. So we know the area. Now what do we know about circles and the relationship between their areas and other kind of things about them? Well, we know, hopefully, that A, the area of a circle, is equal to pi times r squared. So that's what we've got there. Now I know at this point we haven't got a d in here, we've not got the diameter in here, we've got the radius of the circle. But hopefully we also know that once we know the radius of a circle, we just need to double it to find the diameter. So that's pretty straightforward. So A equals pi r squared, so we need to transpose this formula. Now this is the bit where it gets a little bit tricky and people start to fall down a little bit. Again, just think about the order of operation. Reverse that operation and do the opposite function. So A equals pi r squared. We want to get the r by itself because that's going to help us find the diameter. So we want to get the radius by itself. So what are we doing to that r? Well, we're squaring it and then we're timesing it by pi. Okay, so we'd square the radius and then we'd multiply it by pi. So the last thing we'd do to that symbol is times it by pi. So that means that the first thing we want to do is move that pi over. We want to get rid of that pi from this side. At the minute we're timesing that by pi, so we want to do the opposite function, which is to divide by pi. So we end up with both sides divided by pi, looks like this. A divided by pi is equal to r squared, and then we want to get r, not r squared. So what's the opposite of squaring a number? Well, it's square rooting it. So we need to square root both sides of the formula. So that means we end up with the square root of this whole side, a over pi, which again might look a little bit weird, but trust me, the process works, will leave us with r by itself. And again, all we've got to do now is start putting the numbers in. So we'll just flip this around. R is equal to the square root of that area that we brought in earlier, 490.36 millimeters squared, 490.36. Now bear in mind again, this is really important at this stage. We need to put this in as meters squared. Okay, so we're going to put that in as 490.36 times 10 to the minus 6. Okay, it's always good just to be consistent with this kind of thing so you don't kind of throw your answers off a little bit. And then we're going to divide that by pi. So we've just replaced the area, the letter A for the area that we calculated a moment ago. Right, back to the calculator. Okay, so we've got the square root of a number, so we're going to go square root of a fraction, and 490.36, again times 10 to the minus 6, which is what we had before, 490.36 times 10 to the minus 6, and we're going to put that over pi like that. And again, this is why I love this calculator so much, because you can just do all of your calculations in one hit, no problem. Equals, and you can see there we've got 0.01249. Again, this is in meters. That probably doesn't mean much to you in meters, but if we change it in engineering mode into millimeters, we've got that times 10 to the minus 3, which for distance becomes milli. We've got 12.49 millimeters. So we're probably going to round that off to 12.5 millimeters as the radius. Okay, so that radius is now equal to 12.5 millimeters. And again, we're this close now. We know that the radius is 12.5 millimeters. We're looking for the diameter of the buzz bar. And the diameter of that buzz bar, the diameter of any circular section, is just simply the radius times by 2. So we're just going to do the radius, 12.5 times by 2, gives us 25 millimeters. Which means that we have now calculated that this diameter is 25 millimeters. There we go. So that's the answer to the question. The diameter of your buzz bar is 25 mil. And again, if you've managed to get this far, if you've found the area, that's really good. Getting to this point where you work through the transposition of the from the area to the radius to the diameter is a little bit tricky, so it's not surprising if people are struggling with that a little bit. Okay, so let's talk about this other method of finding the diameter. So in engineering, you tend to work with the diameter of cylindrical objects rather than the radius of them. The reason being that it's very easy to get a vernier caliper or something like that and measure the diameter of a cylinder of steel or something like that, or a pipe or something like that, than it is to measure its radius. Obviously you've got to try and find an imaginary centre on there, so that's quite tricky. And wouldn't it be great if you didn't have to mess around going from the diameter to the radius and then find the area? Wouldn't it be great if there was one calculation you could do to get there quickly? There is. That calculation is A is equal to pi d squared over 4. Okay, so that will get you from the diameter to the area. So we can do exactly the same thing again. Just one more step involved in this, which makes it a little bit trickier in this circumstance. So if you use this method, absolutely nothing wrong with it. If we've done this right, this method should get us to exactly the same answer as that straight away. So let's see, I've put my neck on the line here. Let's see if it works. So A is equal to pi d squared over 4, and we want to get the d by itself. So again, with transposition, look at the formula, think about the order of operations, and then reverse them and do the opposite function. So here, what do we do to this d? Well, we square it, then we times it by pi, and then we divide it by 4. Okay, so the last thing we do is divide by 4, so that then becomes the first thing that you transpose, the first thing you move over. The opposite of dividing by 4 is to times by 4. So we say that both sides times by 4, this becomes 4 times A. You could put A times 4, but this is kind of the conventional way of putting it, is equal to pi d squared, because it's cancelled out from this side. What we then do is we look at this and we think, right, I'm squaring the d and then I'm timesing it by pi. So the last thing I do is times by pi. The opposite of timesing by pi is to divide by pi. So we do d squared, both sides of this divided by pi. So we end up with 4a divided by pi. The pi gets cancelled out from this side and we end up with d squared. We want to get d by itself, not d squared. So what's the opposite of squaring a number? It's to square root it. So we square root both sides and we end up with the square root of 4a over pi is equal to d. Okay, so now we've got d by itself, we can do the calculation. So d is equal to the square root of 4 times by the area that we found earlier, 490.36 times 10 to the minus 6. I've been teaching for about, well, a long time, let's put it that way, and every time I do a square root symbol I always forget to leave the tail long enough. I never estimate that right. But anyway, we're going to divide that whole thing by pi, so bear in mind we're square rooting this whole thing when we do this calculation. So back over to calculator corner and see what that looks like in the calculator. Okay, so let's put our calculation in. We've got the square root of, and again we're doing a fraction, 4 times 490.36 times 10 to the minus 6. So that's 4 times 490.36 times 10 to the minus 6. The whole thing over pi. And let's see what that gives us an answer. If we've done this correctly, we should get the exact same answer that we did before. So this should be somewhere in the region of 25. That should be 25 millimeters, of course, once we've pressed the engineering button. There we go. So if we don't use the engineering button, if we just leave it as it was, we end up with the answer in meters, 0.0249 meters, which again, doesn't mean a great deal on first glance, but if we press that engineering button, this turns it into millimeters. So we've got 24.98, which is as near as we need it to be to 25. So therefore, the answer is 25, as we just calculated on our calculator there. So that's fantastic. So we've got the same answer that we had before, 25 millimeters. Don't forget the units. I was used to top my lens off for that. Don't want to forget it myself. So the diameter of this buzz bar is equal to 25 millimeters. We've calculated that in 2 different ways, which is really good. Both methods are equally valid. It just depends which way you prefer. I have no strong preference in this case, to be honest. I probably would have started with that one, I think, because it's just that little bit simpler. You've just got to remember you're getting the radius there, not the diameter. So Helio JJ, I hope that's answered your question. I hope that's kind of explained the transposition element of this in a little bit more depth, which I think is the bit you were struggling with. And of course, anybody else who's been watching, I really hope that that's been helpful. And if you can, please subscribe. Please hit the like button. That would be great. See, I never normally do that, which is why I struggled with it. Yeah, if you've made it this far in the video, you're probably subscribed already. So thanks very much for that. And all that remains in this video is to say thank you very much for watching.